Okay, imagine you have a situation where you have a north-facing magnet falling down a coil of wire. As the magnet is falling down, the induced voltage of the coil will produce a north pole because it will try to repel the north magnet. Right, so let's have a look at the stages. Right, so entering the coil. As the north pole approaches the top of the coil, the magnetic flux increases. The coil induces a north pole at the top to repel the falling magnet. Using the right-hand rule, the induced current flows counterclockwise. At the center, when the magnet passes through the exact middle, the magnetic flux is at its maximum, but it temporarily stops changing. The rate of change is zero. The induced EMF drops to zero, leaving the coil. As the north pole drops out the bottom, the magnetic flux decreases. The coil induces a south pole at the top to attract it back and pull back on the magnet. The induced current reverses and flows clockwise. So let's have a look at the Mach scheme. So the induced EMF is caused by the change in magnetic flux linkage. The EMF is proportional to the rate of change of magnetic flux linkage. The peaks are inverse, meaning that one is the opposite of the other, right? So the EMF changes from positive to negative. The rate of change of magnetic flux linking the coil changes sign. So you can say that the flux linkage increases and then decreases, or a description of terms of Lenz's law as seen by the coil to conserve energy. The EMF becomes zero because the rate of change of magnetic flux is zero when the magnet is in the middle of the coil. The second peak has a larger negative amplitude because the rate of change of flux is greater when the magnet leaves the coil compared to when it enters. The pulses have different widths because the second time difference is shorter because the magnet is accelerating, and the areas under the curves must be the same because the total change of flux linkage is the same on entering and leaving the coil. This is just a different Mach scheme. So you can talk about the induced EMF being proportional to the rate of change of magnetic flux linkage. Initial change in the EMF as the magnet enters the coil closer to the coil. The magnet speed increases as it falls down. The negative value is greater than the positive value. Time for the second pulse is shorter. The areas of the two parts of the graph will be the same because the flux linkage is the same. So if you look at this diagram here, now this one's going horizontal rather than vertical. The induced current produces a north pole on the right hand side of the coil, which opposes the motion of the bar magnet, and the two north poles will repel each other. Remember, we can't have the violation of energy. This is the quarks. The up quark is 2/3, the down quark is -1/3, the strange is -1/3. The baryons have 3 quarks. The mesons have a quark and an antiquark. So if you look at the proton, that's up, up, down. 2/3 plus 2/3 -1/3 is +1. The neutron have 2 down quarks and 1 up quark, and it adds up to 0. The pion is 2 quarks, 1 antiquark and 1 quark. And in this case, you got a third plus 2/3, that gives you +1. What is conserved in a particle decay? Charge must be conserved, mass energy is conserved. Now this is just extra. The lepton number, baryon number, strangeness are conserved. What is a baryon number? All baryons have a baryon number of +1. Antibaryons have a baryon number of -1. Just the baryon number is conserved. Lepton number. All leptons have 1, anti-leptons -1, and non-leptons 0, and lepton number is conserved. Strangeness is conserved in strong and electromagnetic interactions, but not during weak interactions. The above equation gives you the number for strangeness. This is just the evidence for quarks. So this is what they did. They fired the electrons in a proton and they can infer that there are quarks inside the proton. It's just like the alpha scattering experiment, but in this case they're using electrons to scatter the proton. These are the fundamental particles. You only need to know about the electron, positron, neutrino, antineutrino, up, down, and strange quarks. These are fundamental particles.